So before you move to a new homework, make sure you complete the previous one because, like I said, whatever you learn in a homework is helpful for the next one. So complete the missing ones first. Complete the old ones before you start a new one. If you need some extra time, that's not a problem. If you need some extra time, finish the homework. Just make sure you do the old ones and the missing ones before you move on.
So the homework is the number 15. So we can do something that is similar to 15.
Yeah. I'll see the closest one to it. So 15. Let's say, yeah, so 15.
So 14 is closer. No.
14. No, it's a different.
16 is closer.
Yeah, because this is a different question. So let's go to, we're not required to do these, the previous ones. So let's look at number 16. You guys see it, right, on my screen?
Yes.
Okay, so we need to solve this for x. Let me open the board. All right, so that's 7.4. Question 16. So solve.
You're doing better this time.
Am I? Thank you.
Yeah.
I'm learning. I'm learning every day. Okay, so solve. And this is the equation. We did some equations before with fractions, if you remember, but the x wasn't here. The x was at the top instead of the bottom. Those were first degree equations with fractions, but these are rational equations because the x is in the denominator. But the steps are the same. The steps are the same as before. First, you want to get rid of all these denominators. 3x, 5x, 45. We want to get rid of them completely to turn the equation into something simpler like 5x plus 3 equals 7 or something like that. But what is the first thing you do in order to get rid of the denominator? What do you think we do first?
So we first have to move everything to one side.
Say that again?
So first we're moving everything to one side.
Or before that, so we want to try to cancel all these fractions at the same time. What do you think we need to do first to cancel all these fractions? Just like we did before with the equations, with the first degree equations.
Factor it or like find a low common denominator or something?
That's right, find the common denominator. It's already factored, as you can see. Yeah, so this one is already factored here, nothing to factor. So find LCD, find. So it's all about the LCD.
All right, so find the LCD first.
All right, so just like we just did with the previous example, we want to make these the same, all of them. So let's start with the first two here. We want to make them the same. So what do you think we do to these two in order to make them the same?
Multiply by 1, the 3 by 5, and the 5 by 3.
That's right. So they both have x and x, that's good, but one has 3, one has 5. So the common denominator is 15.
15.
Times by 5, also by 5. And this one by?
2.
Not 2.
Well, sorry, by 3.
By 3 to make it 15.
Okay, wait. So the 5 is the common denominator for the first two, you said?
It's 15. So we have 3 and 5. To make them the same, the common denominator is 15. So one will be multiplied by 3. One will be multiplied by 5. And the other one will be multiplied by 3. So far, so good. So these two are the same. But now we look at the next number. So now we turn this into 15. We have 15, but this one is 45. So we need to make them the same. How do we turn the 15s into 45?
15s to 45.
3.
3
times 3.
Yeah, we have to add 3 more again.
Times 3. Let's actually write it down. Hi, Camille. How are you doing? Camille?
Hi, I'm okay.
Good.
How are
All right.
you?
All right. So glad you joined us.
Thank you.
All right. I know you've been having some issues as you emailed me, so take your time to catch up. And email me if you have any questions, okay?
Okay, thank you.
All right.
And you multiply, so the extra 3, we're gonna be multiplying the top and the bottom too, right?
Exactly, exactly. So far, we did the first step, but we had to multiply this one. So we have to multiply this one until we have 45, 15, and 15. So to make them the same, we need 3 here, 3. That way, we will have 45, 45. But at the same time, this one is 45. Is
We
missing
gotta
some.
add the x, isn't it? On
That's
the
right.
45?
So this one is missing x. So we're gonna need x here. And the same thing at the top.
Oh my God, that little problem, you do so much.
Yeah. So this one here, 3, we also need 3 here. And for this one is 3. So 3, 3, 3, 3. And now, as you can see, all of them are the same. This is 45x, 45x, and 45x. We did it in 2 steps, so you can do it here in 1 step if you want to. I didn't want to put all in once. But you can do that if you want, you can do that. Basically, that's the new equation. So we had to multiply this one by another 3. That's how we got 45. So 3 and 3, also 3 and 3. So just, complete the denominators, make sure they have this exact same number and the exact same variable. So this one was missing x, and these two were missing the 45. They were 3 and 5. Now, as you can see, they're all the same. 45x, 45x, 45x. So once you do that, we can go ahead and just cancel all those denominators. Now that they're the same, you can go ahead and just cancel them because they're the same. They will not affect the equation. So we're just going to keep the top side of the equation. So this turns into 10 or 30 here, 3 times 10. What else?
54.
3 times 18, 50. 4
plus 8x.
plus 8x.
Then
Yeah.
actually, you can actually work that out, right?
Yeah, definitely. This
You
is now
can minus 54 to the other side to leave the ax.
So that's a much easier equation. Again, the key word here is to factor. To find LCD. You may have to factor if it's not factored.
So you leave it like that, or you resolve the x?
No, we still have to solve it. We still have to find x. Okay, so that's the reason why we turn them all to the same denominator. Once the denominator is the same, it's an equation. We're not adding these fractions like before. This is an equation. We want to cancel all of them. And this is much easier. Now we can do negative 54. We want to isolate the x. That cancels. We have 8x. And this is negative 24. What is the final step to get the x?
You gotta divide the 8 by 24 by 8 and 8 by 8.
That's right.
Leave with the x alone.
That's right. We want to cancel the 8, so we're going to divide by 8.
And
Also
you got
by 8.
x minus negative 3.
Negative 3. Okay, so the key thing again is to make it the same. So we had initially.
So make sure the denominators are the same, right?
Exactly, to be exactly the same. So we had this, that's what we had initially. So start with the first two and try to make them the same. They both have x, that's good. 3 and 5 are not the same, so we had to multiply this one by 5 to make 15 here. And this one by 3.
Oh, shoot.
By 3 to make 15. So once we made these two the same, the first two the same, that's good. 15x, 15x. But then the last one had 45. So we turned those 15s into 45 by multiplying both by 3. 3 times 15 is 45. But after we did that, this one was missing an x. It was just 45, but since these two have x, that also needs x. That's why we multiplied here these two by x. And once your denominators are the same, just completely get rid of them. That's when the equation becomes much easier, like this. And that's our solution. Okay, so this one is very similar to number 15.
Just give us a second, please. Don't close the board.
Yeah, I'll leave it open. So everyone, please, who just joined us, if you have any questions from the homework or anything, please let me know. And like I said before you do the new homeworks, make sure you complete the old ones. Any missing homeworks from any day, not a problem. Just finish that first before you go to the next homework, because the homeworks are related. One of them actually is important for the next one. So make sure you complete the old ones before you move on to the next ones. So that was 7.4, question number 16.
Now we gotta do something about the 20, right? 24.
The 20, okay, so the 20s.
24, something like that.
All right, so the 20s, something close to the homework. We have question number 21, 23, okay. So that's 21. All right, all these are done the same way. These are 21, let's do 22.
Okay.
Okay, let's do 22 here.
Wait, I'm a little bit confused right now. I think I just missed out a little.
Mhm.
The yellow line which you had there, it was the divide, or it was just something different?
No, it's just it's just pointing to the equation here, right?
Right, yeah. So we don't divide it, right? What is the
No.
minus 54? Where did it come from?
This minus 54, we want to cancel the 54, or you can just move it over to the other side. Okay, it goes over here. You can subtract it, or you can just move it and change the sign. Okay, so we're just pointing out to the equation. It's not a division. It's a subtract, and then division by 8 divided by 8.
And okay, I'll try to solve it.
All right, so let me show you the next one. So 21, 22, all these are similar, so let's do 22. The good thing is this one has 3 fractions, the one we just did. This one, but this one has only 2. It's a little easier. Let's do 22. Okay, let me write it on the board. Okay, so this will be 7.4, and the question is 22. Same question we need to solve. So 5x minus 8 over x plus 2.
X plus 3.
I think I messed up. We're doing 22.
Yeah, the 2x is not it. It's 5x negative 1.
That's right, 5x minus 1.
Minus 1.
Mm-hmm.
And then over x plus 3.
X plus 3.
To resolve that, we have to find the lower common denominator?
That's one way. That's one way to do it. You can do it similarly to what we just did, or there's an even easier way. What do you think we can do when you have a fraction with two, but an equation with 2 fractions?
You
cross multiply.
That's right. Cross multiply. Just like if you had
Cross multiply.
Yeah,
like 5x,
right.
you can cross it out, right?
That's right. Let's say we had this simple, a little simple. So we go like this. We cross multiply. We're gonna do the same thing here. So let's.
Oh, do we need to do it, or we can just find the common denominator?
You can do the common denominator, but I think this way is easier.
Yeah, I don't like the common denominator.
Let me see. We can do it either way. Let me see which one is less work.
And also,
The question is less work if we're crossing it out.
If we cross out, let's see. But we still have to. We'll have to.
So we gotta move the x plus 3 on the top, isn't it?
Let me see. Let me see which one works better, because this one may be a lot of work. You still have to multiply and distribute, combine like terms.
I'm already doing the first one, so I'll see right here.
Yeah, so we'll try to do that. Okay, I believe.
Which one we're gonna follow?
You know, actually, it would be
lower common denominator, right?
Yeah. Well, let me see. Let me tell you. So, I believe it would be about the same. Maybe easier to do the cross multiplication. Yeah, now that I'm thinking about it, it's easier to just cross multiply. So if you have 2 fractions only, Easiest way is to cross multiply. Or if you want to use the same method as we used before, that's fine. You can use that as well. So let's multiply. So it's going to be this times this. Make sure you put parentheses around both. Because we have
because it's moved, right?
Yeah. So this times this. So I'm just going to write them next to each other. And then once you cross multiply, you no longer have fractions. You just one equation without fraction. Then this times this. So x plus 2.
And
so you don't do when the cross and you don't put nothing in the bottom?
No, it's gone. So that's the reason why it's good.
And that's the main reason why you have the parentheses?
Yeah, so no need to find the LCD because this cross multiplication is convenient. It cancels the fractions.
Okay.
Okay.
And when
you want to use
the cross multiplication?
Hold on one second. If you want to use the same method as before, you can do that as well. If you want to find the LCD, just like we did, multiply here, multiply, cancel the LCD, that's fine. But cross multiplication is convenient, but it only works if you have two fractions, one on each side. Okay?
The other, because the other one had 3.
Yeah, that's why we couldn't cross multiply.
Got it.
So now that we have the fractions gone, we can go ahead and distribute. So we still have to do a lot of work. Not easy work, actually. It's a lot of work, but it's nothing too complex. We still have to solve because the question here was to solve.
So that will be 5x squared, right?
Okay, so we're going to distribute both of these. So 5x times x, 5x squared. 5x times 3
plus 15.
15. Then
X.
negative 8.
Negative 8x.
8x
Right?
plus
3x.
24.
And negative 24.
Equals.
That's right. And do the same thing on this side too.
5x squared.
5x squared. It's going to be a lot easier. Now you see it now. It's going to turn out a lot easier than it looks. What else?
Minus x.
5x squared minus
X.
Okay, plus 10x.
Why x?
Plus 10. Because 1 is x. Like anytime it's a regular x by itself is 1.
Okay, so you
I forgot about the 1. Sorry.
1x. Okay, this one is negative 3, negative 2.
It's like 1x. We can put either 1x or x, right?
Right.
That's right.
Thank you.
So something important can happen now. Can you guys look at this and tell me something nice is gonna happen to make this a lot easier?
Yeah, the square is gonna leave like 5x.
That's right. So if you look at the equal sign, you have the equal sign here. And if you have the same thing on both sides, you can just cross it out. For example, 5x to the second, 5x to the second. We can do 5x and 5x on both. Just cross those out. They're gone. Okay. Same thing if you had, let's say, you had 9 here and 9 here on the other side. On the other side here, you can just cross them out. Or you can do 5 minus 5x minus 5x. Okay. So with equations, if you have the exact same thing on both sides, it has to be the same sign. You can just ignore that, cancel it out. So these are gone.
Question, don't you keep the sign of the bigger number when you're multiplying?
No, it doesn't have to do anything with the
like
values.
When you do it like pause. Oh no, because it's not okay.
Right, negative is always positive. Positive, negative is always negative.
Got it. My love, my bad.
Okay, so we're gonna cancel these two. If you have something exact same thing on both sides with equal sign, just cross it out. Now we're gonna simplify what's left. We can combine these two. What do you get? Negative 15 plus
39.
No, we have negative and positive. That's
Can we just leave x's on the left and we can just move all the numbers to the right? So
but before that, let's simplify. Let's simplify each side first. Before we do that, work on each side.
Negative 1x. I mean negative 1x, yeah.
So we have 15 minus 24. Sign of the higher is negative. And what else? What is 15 minus 24?
Negative 9.
Positive 15 minus 24 is negative 9.
Negative 9. The sign is negative.
It's 15x, right?
I'm sorry?
It's 15x. How can you?
15x? No, it's not 15x. It's 15?
It is 15x.
Yes, it is.
It is 15x.
Oh, maybe. Let me see. So 5 times.
Oh, yeah.
Yeah, you're right. Thank you. You're right. Correct.
I
So,
thought I was wrong. I stood out.
no, you're good. So now, I changed things a little bit. You're right.
OD.
Quick
And
question.
then
When can
15
we,
minus 8.
Okay, one at a time. Go ahead. One of you.
yeah, I was just asking that when can we multiply it like this,
Okay.
like when we are crossing? Only when it's equal to each other, right?
Yes, when you want to cross something, it has to
No,
be.
no. Like when we start doing it, like when we are getting rid of the denominator and we multiplying it, we can do it only with an equal sign, right?
That's right. That's right. So
And
now
only if
let's.
it's two of
Yeah.
them. Okay.
That's right. So now, back to this slide. What do we do here?
So
So then
15
it would be 7
X minus 24.
minus 24
That's
equals
right.
9x minus 2.
7x minus 24.
Equals 9x minus 2.
9x minus 2.
Exactly. 9x minus.
Oh, killing it.
We're doing it right.
What do we do now? What do we do now? We
We have the x's in one side and the regular numbers on the other side.
Exactly.
So minus 9x.
That's right.
So it'll be
move
plus.
x over, and also gonna
No.
move negative 4 over to the
And
number.
then plus 24 to the other side.
Okay.
All right.
So negative
So
9.
then we got 26
Negative 24
equals
moves over becomes
negative 2.
positive 24. And what is this equal to? Negative 2x. And
you could do that,
that's right. And 20.
right? And then divide by 2, and then your answer would be
That's by negative 2. By negative 2.
negative.
X will be
Negative 11.
Negative 13.
negative 11.
Oh, I'm off.
Okay, so remember the main steps here. Cross multiply and simplify. Okay, those are the main steps.
All right.
It looks like a lot of x's and numbers, but the main step is to cross multiply here. Once you do that, solve your equation normally. There could be slightly different ways to do
You don't
this.
like
You
them?
can move, if you want, you can move all these to one side first and change the sign, but you do it the way you feel is easier or comfortable. Or you can also use the LCD as we used before, but I suggest when you have only two fractions, don't worry about the LCD, just cross multiply.
Okay.
Okay, so that was that question. And the rest of them are the same way, just cross multiply. Addition and subtraction of radicals, multiplication of radicals.
How about nothing for around 40s and 50s that you gave us?
There's only 145. Let's see what 45 is. Is that under the same question? Yes, it's under the same question. 45 is this one. Okay, so this one has three fractions. So we'll have to do just like the first one. Just like we did 16. We have three fractions. We can't cross multiply.
So you gotta find the LCD and then
That's right.
simplify.
You gotta make them the same. So you can't make,
All right.
yeah, so 45 is three questions. Let me see, I think homework 14 might be redundant a little bit. Homework 14, it's addition and subtractions. We already did addition and subtractions.
You say 14?
Some of it probably redundant. Didn't we do already the addition and subtraction of radicals? No, that's a different type.
I kind of lost it on like 16. I mean, I solved the 22 like before, but I don't get a -3 when I solve it if I don't look at this.
Which one?
The first one. When I solve on my own, I don't get the -3.
16.
Mm-hmm.
Well, let's see if we made any mistake here.
No, I'll just tell how I do it. Like what I was doing is that again, like I was finding the common denominator.
So let me check. Let me check. One of us is wrong, either us or you. Let me see. I'm gonna check the answer real quick and see if we made a mistake. That was number 16. 16 is here. This one. No, actually, it should be -3. Yeah, just
It
double
should be
check.
-3.
Yeah, just
Yeah.
check your signs.
You when you are like the denominator when it comes to 45x,
Mhm.
do they immediately cancel it? Do they even have the right for it? Like why don't we divide it? Why don't we keep it?
No, we don't need it because we want to we want to solve.
They're the same.
So when you solve, this is an equation. We're not adding fractions. We're not doing this. If you add in, for example, 2 fractions, if you add in these 2,
Right, we're not
not an
cancel
equation.
it.
Then you have to keep the denominator, 10. Then simplify it into 2. But with equations, we're not adding fractions. We actually want to get rid of them. You want to cancel them. Let's say we have 3 over, let's say a plus 4 over a, and maybe another number 5 over a. So when you have an equation, not just fractions, the equation with fractions, and if the denominator is the same, it's irrelevant. You can just cancel it, and you just say something like this. This is just a random example I made, but once you make the denominator the same, any equation, not in fractions, add and subtract. When you make it the same, you can cancel it.
Right.
Okay, so we were looking at something else. What were we looking at? Yeah. So okay. So for the 45 or 46, you're gonna have to find the LCD because it's three.
You said it's the same as the three numbers, right?
As the 16, yes. So you have to find the LCD for all of them. But again, remember, if you have 2 fractions only, like here, it's easier. Don't worry about the LCD, cross multiply right away.